Hello, welcome to another exciting learning time with Mafeng. So in this video, we are going to be talking about decimals and fractions. Now, you would agree with me that decimals and fractions are different ways of representing numbers. But then we have to know that there's a relationship that decimals and fractions do have. So numbers that are whole as well as numbers that are not whole can be represented as decimals or fractions. So you must have seen something like this. Let's say we have 2 over 3. Now this is a fraction. This is a fraction. We have various types, of course. Now, you must have seen numbers like this again. So let's say 25.896. Now, a number like this is called a decimal. How do we identify decimals? With a point. You only see a point there. So such numbers like this are called decimals, while something like this are referred to as fractions. Now you see that decimals is made up of two parts, just like fractions is made up of two parts. We have the numerator and the denominator. Well, for the decimal, it's made up of two parts. So what am I simply saying? We have here, which is called the whole number part. This is called the whole number part. Now, you can see all the digits that we find before the decimal point are whole numbers. So that's what we call this part, the whole number part. And then we have this part after the decimal point. We refer to this as the decimal fraction. The decimal fraction part. So you have to know that the decimal fraction part is not whole. It's not whole, but these numbers before the decimal point are referred to as the whole number part. So we can see that decimal numbers are made up of two parts, which are the whole number part, and then we have the decimal fraction part immediately after the decimal point. So you can see when we want to call this out, we say 25.897. Now, that takes us to talking about the place value of decimal numbers. The place value of decimal numbers. Place value of decimals. So going back to that example, we have 23.896. Now we'll see that for the whole part, we have two digits here. Of course, we can have so many examples of decimals, not necessarily two digits. We can have more than that. We can have something like this, maybe 125.83. We can have 1000.61. And you can see all these are decimals. How do we identify decimals? The point here, the point. You can see here we have a point here, we have a point here. Now we have the whole number part, and then we have the decimal fraction part. You can see here the whole number part is 125.83, and then here that's the decimal fraction part. Now looking at this, talking about the place value of decimal numbers. So we are going to tell the place value of each of these digits, what they stand for. Now don't forget, as I said earlier on, that this make up the whole number part. So let us assume we are having 23. Now how do you identify the place value? You can see here will be the units, and then here will be tens. So we have 2 tens, 3 units. But then when we introduce the decimal point and then we have those digits, we have 8, 9, 6. Now you see that the place value of the digits before the decimal point doesn't change. In fact, the last digits that we have before the decimal point is actually the unit place, and before that is the tenth, and so on. We have the 100 here, and it goes on that way, just like we were told in whole numbers. But then immediately after the decimal point, what is the place value of 8? We say the place value of 8 here is going to be tenths. It's going to be tenths. That is 8 tenths. You can see with the TH and S. So you are going to see that sometimes we are going to have it this way with this TH this way, right? Now here, the place value is hundreds. Hundreds. And then here, the place value is thousands with a TH. You can see that? So you can see 8 tenths, 900, 6,000, and it goes on that way. Just like what we have here, unit, tens, 100, 1,000, 10,000. Likewise here, we have 10. So we don't have the units, it's only here. We have that's 3 units. And immediately after the decimal point, this is 8 tenths. You can see TENTHS. That is 8 tenths, 900, 6,000. And it goes on that way with the 10,000. And we have that. That is the TH at the end. Now you have to know that these numbers here, these digits here, immediately after the decimal point are usually fractions. And that's why we say here is the whole number part and then here is the decimal fraction part. So I can say that the place value of 8, place value of 8 is, here I have 8 tenths. It can also be written as 8 over 10. And that's why you see we have 8 tenths. That is 8 over 10. Or it can be written as 0.8. So if you are asked the place value of 8, when you write 8 tenths, you are absolutely correct. When you write 8 over 10, correct, all the same. When you write 0.8, absolutely correct. That is the place value of 8 in this particular number. So the place value of the digit 8 is 8 tenths or 8 over 10 or 0.8. Don't forget I said the place value of the digits before the decimal point usually remain the same. They are always the same. You can see here we have 3 units, we have 2 tenths, and that's why we don't need to, I'm not stressing that. You can see with the TENS. But when it's here, it has the TH, the S at the end, and then here we have units. Why? I believe that, of course, we are familiar with this. Then we have the place value of 9 is 9 hundredths or 9 over 100. Or again, you can see we have 0.09. Now you can see that this is quite easy to relate this with this as well as this. 900, that's 9 over 100, 9 out of 100. You can see here we have 0.08. So I'm going to explain this later on in this video. We have the place value of 6 is 6,000 with the S, or just like this, you can easily guess that. That's 6 over 1,000, or you are going to have 0.006. Now, how did I get this done? You can just see that to find the place value of 8, I'm going to simply make all this to be 0, all the other digits aside the one that I am interested in. So when all these other digits are 0, we have 0, 0 here, which is same as 0. You can see it collapses to 0 entirely, and then all the other guys, these other digits that we have here, they are zeros, and then here we have 8, so this is 0.8. We can also have this here, 900, that is for this. You can see all these are 0, this becomes 0, you can see that here, 0, and then we leave this particular digit, so that's why we have 0.09, and then it goes same for 6. You can see making all these zeros except for 6. So that's why we have the 0.006. So this is the place value of this digit in this number. I believe it's quite clear. So that's why when we are calling out the numbers in words, we don't say 23.896. That will be wrong. Now, the way we pronounce numbers, the way we call out numbers, whole numbers, still remains the same for the whole number part. But when we come to the decimal fraction part, we call out each of the digits. So what am I simply saying? We can write this number, or rather we can call this number this way. We can say 23.896. That's how we call out this number, 23.896, not 23.896. That will be wrong. So it is 23. So I'm going to write that in words, 23. And then we have point, again, we have 0.896, just to emphasize the point here. But then we don't need this. So if we have to call out this number, we can say 23 and then 0.896. Another way we can call out this number is to say, now looking at, we have 23 here, which is the whole number part. Then for the decimal fraction part, we are going to look out for the last digit, the place value of the last digit. So we can see that the place value of the last digit here we have is 1000. So I can say 23.896 thousands. 896 thousands. Now that is another way to call out decimal numbers. But then I'm going to say the easiest way to go about this is to say 23.896. So for something like this, this is 125.83. 125.83. This here is 1000.61. Not 1000.61. Nope, it is 1000.61. Now that is exactly how we call out these decimals. Now I would like you to also know that there's a relationship, as I said earlier on, between decimals and fractions. They are actually relationships. So it's just, think of it as same you wearing wearing different clothes. So you are in school, you are in your uniform, and then at home you are in another wear. So now, but it's still same you. So numbers can be represented as decimals, and those same numbers can also be represented as fractions, all the same. So let me give you an example. So let's say we have this number 1/2. Now this is a fraction. Now how can we be able to change this to a decimal? Now we have to bring in our knowledge of division. So I'm going to have something like this. This is 1/2, which is same as saying 1 divided by 2. Now whenever you have something like this, you can see this is the dividend and this is the divisor, and you cannot be able to bring out 2 out of 1. So if you are asked, how many 2 can I have in 1? Obviously, you will not be able to bring out 2 out of 1. That's a whole 2 out of 1 at the moment. So what we do in this case, we are going to introduce a point, and then we add 0 to this. We're also going to put the point here that we actually have. Or better still, we can just say, since we have this, we cannot be able to bring out 2 out of 1. We are going to write 0, since how many 2 can I have in 1? I can't bring out a whole 2 out of 1, so I'm going to write 0 and put the point here. And then I'm going to introduce a 0 here. That's another way you can go about that. So you can see how many 2 can we bring out of 10. So yes, I can be able to bring out 2 out of 10. How many will that be? That will be 5. So you can see that 1/2 is same as 0.5. Now 1/2 is a fraction, 0.5 is a decimal. So think of this, someone will say, okay, I have 1/2, and then someone will say I have 0.5. They are both saying the same thing. It's just that one spoke in fraction while the other in decimal. So you can say 1 over 2 is same as 0.5. Now don't forget, if you are converting fractions to decimals, you have to have a very good knowledge of division. You have to have very good knowledge of division. Let me take another example. So let's say we have 5 divided by 4. If we have 5 divided by 4, I want to represent this in decimal. So to do that, I'm going to have here 5 and it's divided by 4. Now you can see this is quite different from the previous example. How many 4 can I have in 5? Of course, I can be able to bring 1. So that is 1, right? And I'm going to be left with 1. Out of 5, I can bring out 1 4 out of 5, and I'll be left with 1. I'm going to be left with 1. Now, can I be able to bring out 4 out of this one? No. So I'm going to introduce the point and then add 0 to this. So it becomes 10. As you can see here, it becomes 10. Now, I'll go over the process again. How many 4 can I have in 10? And that will be 2. So I'm going to have 2. Remaining 2. Don't forget that this is 10. I bring out the first 4. I bring out the next 4. That makes up 8. And I'll be left with 2. So how many 4 can I have in 10? I'm going to have 2 4s in 10. And I'll be left with 2. So you can give a space there and put this here. I'm left with 2. So this is the 2 here. And this is the 2 that is remaining. The number of 4s I'm going to have in 10 is 2. And I'll be left with 2. Now, how many 4 can I have in 2? Can I bring out of 2? Again, we are not going to introduce another decimal point. Only one decimal point which we are expected to have in this number. So, since we cannot bring out a full 4, a whole 4 out of 2, what we are going to do in this case, we are going to add up 0. Initially, we're going to put point before adding the 0, but no, since we have already put this point, we don't need to put another point. So we just go straight up and add 0 to it. So how many 4 can we have in 20? And that will be 5. So we have 5 here. So you see, 5 divided by 4 is the same as what I have here, 1.25. So I have 5 divided by 4 is same as 1 point, this point here, 25. Remember, this is not 1.25. No, it is 1.25. Now, let's look at other examples again. So I have here another, let's say we have 8 over, let's say maybe 5, 8 over 5. Now, how can we be able to convert this fraction to decimal? Again, we're going to have this here, that is 8 divided by 5. Now, how many 5 can we have in 8? That is 1, remaining 3, right? So I'm going to have the remainder 3 here, isn't it? I'm going to bring out 1 whole 5 out of 8, and I'll be left with 3. Now, can I bring out 5 out of 3? No. So I'm going to introduce this point and then add 0 to this, and it becomes 30. So how many 5 can I bring out of 30? And that will be 6. I'm going to have 6 5s in 30. So that simply means that 8 over 5 is same as 1.6. Now, you can write this as 1.60. Now, when you keep adding up zeros to the decimal fraction part, it does not change the fraction. It does not change the decimals. What am I simply saying? Take, for example, we have 1.6 here. When I add several zeros to this, it doesn't change this. It's same as 1.6. This can be ignored, or this can be ignored, of course. We can throw this away and it will still be 1.6, and that's because we are adding zeros to the decimal fraction part. But it's not the same for the whole number part. For the whole number part, every zero we add makes the number bigger. But for a decimal, when we keep adding more zeros, several zeros to this, it does not change the fact that this is still 1.6. Now, I'm going to teach you a trick. Whenever we are having decimals that have to do with 10, or rather fractions that have to do with 10, 100, and 1,000. That's fractions whose denominators are fractions with 10, with 100, 1,000, and so on as denominators. Now, this is quite easy converting these fractions to decimals. So take, for example, I have 8 over 10. 8 over 10, and I'm to represent this as a decimal. Now, of course, you can still go over the same thing I did the other time. 8 divided by 10. How many 10 can I have in 8? Of course, I'll not be able to bring out 10 out of 8. So I'm going to just have 0 here. I'm going to put my point. And then since I've introduced my point, I'm going to certainly add 0 to this 8. It becomes 80. So how many 10 can I have in 80? And that will be 8. So that means this is 0.8. This is 0.8. So 8 over 10 is same as 0.8. But there's another easier way of going about this. So let's say we have 8 over 10. Now, what I'm going to do here to make this faster, I'm going to say for every whole number, there's a decimal point. What am I simply saying? If I have a number like this, 3, let's say I have 3 as a number, I can as well introduce decimal point and add 0 to that. Now this is 3.00. Again, it does not change the fact that this number is same as 3. So what does that simply mean? It means every whole number have a decimal point at the end. Every whole number, of course, have a decimal point at the end. So I can have this as 3.0 is still the same as 3. So looking at 8, I'm going to introduce a point there which doesn't change the number. So whenever I'm dividing with 10, how many zeros do I have here? That is 1. So I'm going to move it one step to the left, and it's going to be here, and that becomes, so once it is here, I'm going to add 0 to this, so that gives me 0, then point, and my 8. So you can see, looks very much the same with what we did earlier on, dividing this. So you can see, I'm still going to take an example like this again. Let's say we have a number like this. Let's say we have the second one. Let's say we have a number like this, 12 divided by 100. And we are to convert this to a decimal. So I'm going to say this is 12, and then there's a point here. How many zeros do I have in 100? And that's 2. So I'm going to move 2 steps, 1 and 2 here. So I now have my point here, right? Maybe I should take that with a different. Okay, so I have my point here now, and then I'm going to have 0 here. So this becomes 0, 0, then this point, and then I have 1, 2. So you can see that 12 over 100 is same as 0.12. Let's also look at other examples. Let's say I have 8.3 divided by 1,000. 8.3 divided by 1,000. Now you're going to see here, there's a point there already. So how many zeros do I have as the denominators? I'm having 3 zeros. So I'm going to move 3 steps to the left. So from here, this is 1, this is 2, and this is 3. So I'm moving 3 steps. Now for every vacant space that I have here, now don't forget, the decimal point is now here. Yeah, that's a good 1, 2, and 3. Now we have vacant spaces here. So I'm going to fill that up with zeros, zeros, zeros this way. right? So it goes 1, 2, 3. And those vacant spaces, of course, I'm going to have a 0 before the decimal point. Here, just 0.00. So to write this in a proper way, this becomes 0. That's this point. Maybe I should make this with this color. Okay. So I have 0, and I have this point here, and then 0, this, and then another 0, this, and then I'm going to have 83 because the decimal points have moved here. So I'm going to have 83. So 8.3 divided by 1000 becomes 0.0083. And one quick example again. I have, let's say this should be the fourth example. So let's say I have 123.58 and divided by 100. So how do I go about this? That is changing it up to decimal. And again, same thing I did. How many zeros do I have in 100? I have 2 zeros, so I'm going to move 2 steps to the left, and that will be 1 and 2. So my decimal point will now be here. And to write that up, it becomes 1. Don't forget here, except if we don't have any digit here moving, and that's where we fill it with 0. So you can see we have 1 here, this 1, then point. I have 2, 3, 5, and 8. And so how do I call this out? That is 1.2358. That's how I call this number. So I believe that this is quite simple, and I believe you understand that. So I'm going to be still uploading more videos, so don't forget to subscribe to that, so that I'm going to put in a lot of videos for you to be able to learn. So I believe that math is fun. Bye-bye.